Hello everyone, welcome to the channel and I hope everyone is doing good. So in today's video, we are going to look into the RAG interview process. So I have seen many data engineers who has some exposure of the GenAI pipeline or who has studied something about the GenAI pipeline, have done some of the POC for the learning purpose, get stuck in the RAG interview question. So in this video, we'll break down we'll try to break down almost all the interview question from the beginners to advanced level. These are not very much into the scenario based interview question, but these are the interview question which you should know before going into any of the AI interview or any of the Gen AI interview panel. And if you have not subscribed to our channel, please subscribe to our channel and do share this video and channel to your colleague, to your friend who want to build their career into data engineering field or who want to have a better understanding of Gen AI topic or data engineering topic. So let's start now. So let's start with the basic question like what is RAG? So RAG stands for Retrieval Augmented Generation, in which we gather information from some external sources and that information is sent to the LLM model as a context and we put our own question into that, and with the help of that question and from the external source of the knowledge plus the model or LLM model in which it has been trained the previous data, including all this thing, LLM gives you one concrete answer. So with the help of RAG, we just form the answer in which we have the external information also and the knowledge or intelligence of the LLM. Now the second interview question or the second question which will come with this is why we need RAG, why RAG is important. So before going into it, we should understand that why we need RAG. We can directly ask the question to LLM, but that will not give you the correct answer every time. Your LLM model will be trained and with some data or will have the training timeline. It may be trained 1 year back or 6 months back. So if you ask any question which is very latest question or which has the very latest answer, in that case, RAG will or in that case, sorry, LLM will face difficulty in giving the answer and it will give you the wrong answer. Second thing is in the existing scenario in the LLM, you cannot add any external source. For example, if you're working on an in insurance company and you want LLM to find the answer from some of the insurance documentation which your company have. So in that case, your LLM model don't have access to document. So we want to add some external source or our external source is the insurance document. So for in the RAG, we can add the external source in the LLM. So for this purpose, RAG is important. Then another problem with LLM is hallucination. That means LLM gives the answer with 100% confident or near to 90% confident, but due to some of the parameter like LLM learning process or the training was done way back, because of all that factors, the answers are not factually correct. And for that, the RAG is very important to update the information of the LLM by providing the source from an external source. The whole purpose of RAG is to give the external source information into the LLM to make your answer a contextual answer and to make your answer more logical and factually correct. Now we'll move to the another question. Like, can you explain the RAG pipeline? So the interviewer is asking you to explain the simplified RAG pipeline. So RAG pipeline consists of few steps, like there's a data ingestion, when how you ingest the data, then chunking of the data, like you have multiple PDF as a source, then you have to chunk this information into small pieces on the basis of range chunking or some logical chunking. There are different ways to chunk the data. Then embedding generation. Embedding generation is the process of converting your information into multi-dimensional vector. Means giving a numerical values to your information. So there are ways and there are Python libraries to create the embeddings. So embedding is basically creating a multi-dimensional vector for your data, and that embedding is then again stored into a vector database. There are multiple vector databases like Pinecone or ChromaDB. So you can use vector database to just store this embedding. There are multiple vector database in which you can create the embedding and store it at the same time. And from the process wise, you can create the embedding outside the vector database, and then with that embedding can be stored into a vector database. Once your information is stored in a vector form, then your queries are then converted into embedding. Like the vector values are again generated for your queries. Queries means your question, user question. Then the steps come prompt augmentation, in which your retrieved information is moved or is put into the LLM as a prompt. See, you have the embedding, actual embedding. Just a second. So you have the actual embedding stored in the vector database that has the external source information like from the PDF or something. Then you have user query embedding, and then the semantic or near to vector search is done, and that information is pulled and put it as a prompt to the LLM, and then LLM generate the response in a proper fashion, uses intelligence to create a well-defined answer. So this is a general RAG pipeline. Now, at sometime the project will generate the embedding and store the embedding at the same place in a vector DB. So that is also part of this pipeline. But this is the very simplified, and this is how the basics of RAG is being done. Now, moving to the other set of questions. The other question is, what causes hallucination in RAG, and how you can improve the RAG performance. Like in the starting of this video, I have mentioned that in the LLM has the hallucination problem, and for that RAG is there to like reduce the hallucination in the LLM. But hallucination can happen in the RAG because of multiple factors. It can happen in the RAG also. So RAG helps in reducing the hallucination in LLM and the model, but still the hallucination can happen in the RAG model itself, in the RAG pipeline also. And there are few reasons for that. The first reason is poor retrieval. As I have mentioned, in while doing the retrieval of your information from the vector database, from the embedding, the poor performance of your vector database can lead to the poor retrieval of your semantically correct answer, and that will be one of the major cause for hallucination in RAG. Irrelevant chunks, again, if the poor retrieval, maybe the performance of the speed of the retrieval, which will also include the irrelevant chunks. Weak prompts, if you give the weak prompt in the RAG, obviously it will not give you a proper formatted or proper contextual answer. Low quality embedding, if you're not creating the embedding in a proper way, there are like chunkings in a proper fashion, or if we have a overlap chunks, in that case we call it a low quality embedding, and that will eventually lead to the hallucination problem in the RAG. Missing context, while you create the prompt, you don't give a proper context, or you don't just follow all the prompt technologies or prompt method which is used for a better prompting method. So all these factors are there too, which causes some of the hallucination in RAG. Now, to how to improve the RAG performance, I'm talking about the overall RAG performance improvement. So, as for the RAG pipeline, there are multiple steps like chunking, embedding, querying, getting the retrieval of the data. So, as per the different phases, we can have a better things in different phases to have a better performance. So, how will improve the RAG performance? First is a retrieval optimization. We can have a better embedding. We can have the hybrid search. We'll talk about the hybrid search in the next question. Then we have a re-ranking. We can do the re-ranking, but better embedding is the biggest factor in which your retrieval process will be very good. Then chunking optimization. When you create the chunks, then you can have create a chunks in a different way. We will see this also in some other questions. You can have a dynamic chunks. So any chunks you create while the chunking process, be sure that your data doesn't overlap in any of the chunks. When the same data doesn't get repeated in the other chunks, that will create the hallucination in RAG, or that will give you the wrong answer. Prompt engineering, if you don't follow the proper method of the prompting process, missing context, weak prompts, obviously your answer, the LLM will be not able to get the proper context from this prompt. Then infrastructure optimization you can cache the information, like you are asking multiple questions which are very similar to that kind. You can cache that information. You can do the parallel retrieval. You can do metadata filtration before getting into the LLM as a context. We can do the metadata filtration before that. So these are the way you can improve the RAG performance. So like as I have told in this video, the question will be straightforward to the RAG. That can be the advanced question, but it will be straightforward, no scenario based question. For the scenario based question, I'll be coming up with another video. So now we'll move to the another question. So now the next set of question is what is hybrid search and what is re-ranking. So first we'll look into what is hybrid search. So generally the pipeline which I have explained about the RAG, we look for the semantic answer from the vector database. But semantic search has some of the disadvantage. So now to have a better searching, better answering, so we use a hybrid search. We use a traditional search, which is a keyword search. Like I want something, I want the exact word to be matched in our on our database. And other is semantic search. So we combine both keyword search and semantic search to create the answer. Now, to make you understand in a better way, like for example, I have a question like how to reset password in AWS. In the keyword search, it will look for the reset option, reset password, AWS. These are the keys. It will look for these keys into your document. If it find the answer, it will give you the answer. Otherwise, it will be not able to give the answer. But if I write the question like steps to recover credential in Amazon Web Services, like in my document, I have this line and my question is how to reset password in AWS, then the keyword search will not be able to identify this line as the correct line for your answer, means this starting of this line. But in semantic search, it looks for the near to answer. It will look for the semantic meaning of that question and answer. So in the semantic search, it will understand that reset password and recover credentials are both the same thing, and it will be able to give you the answer. It will in the semantic search, it will also identify that AWS equal to Amazon Web Services, and it will give you the correct answer. So in most of the cases, keyword search will work if the keyword matches. Sometimes semantic searches doesn't give you the correct answer. It will give you the near. It will try to give the near to answer, but that answer will be not factually correct in some of the times. So the best thing is the user fires the query, do the keyword search, do the semantic search, combine the result, re-rank it, put it into the LLM, give it to the LLM as a prompt as a context, give the proper prompting, and then you will get a very refined output. Okay. So this is will be a more CPU intensive process because we are doing the keyword search also and we are doing the semantic search also. Keyword search can be into another document, directly into the documents or database, and semantic search will be on the embedding. Obviously, we do that semantic search in the embedding, which is stored in a vector database. So this is what is hybrid search. Now we'll look into what is re-ranking. So re-ranking is a process of re-ranking the document retrieved from the vector database in a more uh, preferred way or the more accurate way. I mean to say, like during the hybrid search also, there are chances you may get the answer, you may get the answer which is not factually correct, which is not very near to answer. There can be multiple noises in your hybrid search answer. So in that case, if you are getting multiple kind of similar answers from the vector database, from the documents, so in that case, we can re-rank the documents as per their relevance from the model itself. So like a user fire the queries, you retrieve the answer with the help of vector database, keyword search, and you got around 20 documents which are relevant to your the user query. Now the re-rank model will rank these 20 documents into top three documents, which is more relevant, and then this three document is sent to LLM as a context. If we don't use re-rank model, and if you have got 20 relevant or near to answer a document, so this 20 document will be sent to LLM, and it may create noise in your answer. So before sending to LLM, you can have the uh, relevant document, top three relevant document creation with the re-rank model. Yes, this is time consuming and this is bit more CPU intensive because you are again using some logical curve to re-rank the document. But in the scenario where your answer or the accuracy of answer matter more, you don't want much of the noise, for example, related to some insurance documents, some company policy documents. In that case, a re-rank model or establishing the re-rank model in your RAG pipeline is very important. But if you don't need re-rank, you don't need much of the accurate data, means uh, from 100, around 10% of data can be a missed data, can be a the factually incorrect, then also it works for your application. And in that case, it's not advisable to go with the re-rank model. Now we'll move to a bit more advanced question, but it is not a very much scenario based question. It's a straightforward question. Like, how would you design the enterprise scale RAG? Like, we know what is the RAG process. So it looks simple, it's very easy to design, but from an enterprise scale, you need to focus on the optimization, you need to focus on the costing also. You need to focus on getting the better result in less time, and by spending less amount of money. So for designing the enterprise scale, there are like these are few of the points you need to keep in mind. Like, there must be multiple stage retrieval. Okay, you don't need to retrieve the data in a single stage. You should have the hybrid search. You should have the metadata filtration before it reaches to the LLM. Re-ranking model can be implemented. Caching of the result can be done. Monitoring pipeline should be established there. Access control of your RAG pipeline by using multi-tenant architecture, role-based. There are multiple ways you can do that. These are the few things you can look into before designing the enterprise scale RAG. If you're going into any discussion of the RAG architecture discussion, then you can have this points. You can keep these points in the mind and get this answer before going into that call. And then you can have a better. You can place your idea in a proper way with a proper logical support to your answer. So now we have another advanced question, like, what are challenges in the RAG when you are working in a production environment? So the first challenge is high latency, let's say high duration of time before getting the result. Vector DB scaling, in case your embedding in size increases, your input source PDF size or any of the input source data increases, then how you will scale the vector DB? It's not so simple as we do in another database. Security, because in the security you can have the prompt injection attack, you can have multiple attack in your vector database. Cost optimization, data freshness, how fresh your embedding is. Like, if your PDF, one of the embedding is having outdated knowledge, then LLM will give you the same answer as you have in the vector database. So your vector database should be refreshed periodically as per the requirement of your application. Then hallucination is one of the problem. We need to look into it. This is one of the biggest problem. But data freshness is the key thing you have need to keep in mind. If you do the data freshness every time, then that will be a CPU intensive. It will cost a lot. So you should understand your application when your data should be refreshed. Now, these are the questions which we have discussed now. Why RAG is important, what is RAG, can you explain RAG pipeline, hallucination, and RAG improve RAG performance. These are questions. Apart from this, you should also look into what are different types of chunkings, how we do the embeddings, what are the commands for doing the embedding. In the chunking also, what are different types of chunking and where it should be used. These all questions are also important, which I have not covered it, but obviously you should look into it. So this was all for this video. I hope this will be useful to you. If you have any doubt in any of this question which I have explained now, just put it in the comment box. You can reach me through my LinkedIn, or you can also reach me through the mail. I'll try to help you, and as per possibility I can do. Till then, happy learning and goodbye. See you in the next video where I'll try to put the questions more from a scenario based perspective. Thank you.